No, it's great to be here. Thanks for the invitation, and thanks to the ROS-Industrial Asia Pacific team for organizing this and inviting us here to talk today. So ROS-Industrial Consortium Americas, right? We're hubbed out of Southwest Research Institute. We're based down in San Antonio, Texas, in the United States. So I've been around since '47. Like to advocate we're independent, so we win all our work focusing on natural science and engineering. We like to say deep sea to deep space, because the work that goes on across the campus is literally, either working on submersibles that dive on deep sea applications, and of course we even steward and lead space missions like New Horizons. Relative to Southwest Research Institute and robotics, in the group I work in, we focused on advanced system development, right? And that actually, you may have heard, right, ROS-Industrial is 10 years old, and it was actually building a lot of these high-end and high-performing systems, or systems that have to do a lot of interesting things in like dynamic environments, that led our group to investigate ROS as a solution. And that was actually the birth of the ROS-Industrial program. So these are just a couple examples. Inkjet printing on aircraft surfaces, and this is laser ablation, basically coating removals for aircraft. And it's basically a lot of the core work that our team does. We take advantage of the tools in ROS and give back as well, right? So we live and we try to walk the talk, if you will, right? So that's what our team does. There's obviously, we've heard a lot about it. I don't need to belabor a lot of these points. We've heard about vendor lock. We've heard about advances in AI and vision, and obviously people wanting to have systems that work a little bit more efficiently with and around people, right? So basically, one of the things that we've tried to do are develop solutions that do these sorts of things, right? And I think this community as well here in Asia Pacific and our broader ROS-Industrial community all has those same things. Let's take advantage of advancements. Let's enable new applications, but we need to be cognizant that people still do good things, right? And the systems have to work well with people. So hey, ROS-Industrial, right? We talk about ROS-Industrial. I often get asked, what is the difference between ROS, ROS-2, and ROS-Industrial? Hence the graphic, right? So we have at the bottom ROS or ROS-2, and then we have ROS-Industrial, right? We just, in very short, right? We just seek to extend ROS and ROS-2 and all that good stuff that's there into industrial applications and taking advantage of industrial hardware. That's the mission. So I always like to kind of bring it back to that. And I mentioned and you heard ROS-I is 10 years old, right? So thank you to our friends here at Asia Pacific and members and university partners for providing content for our 10-year mashup, right? So a number of you may recognize a number of these applications. It's really great to have a thriving ecosystem. The Consortium in Americas, it's very valuable to have when you have a number of people that are willing to tell you everything that's missing and what's not working and how you can do better, but that's invaluable, right? That's how we get better, right? Is having people, having get-togethers like this, talking about challenges, what's missing, and doing new work, providing new resources, and then getting feedback on those new resources. And so this highlights a number of the different applications and things that we've worked on globally as a global team, right? So, and it's an FCI video we talked about, Christoph. Anyways, so a number of neat applications. I think Daryl did a great job of bringing up the member map. But what's really key, and it's very much true for us as it is for Daryl and after me, Christoph, is that it has to inform what we do, right? We've heard about interoperability. Lo and behold, interoperability is one of our four main thrusts, right? Obviously, we're very concerned about human interface and reaction. But ease of use is something we get asked about quite a bit, right? We were talking earlier about working with containers and building from source to facilitate ROS-2 humble bridging. And no, that's not easy, right? So we obviously want to focus on those, provide tools and things that actually make these resources easier to take advantage of, right? It's really important. More recently in the Americas, we've really thought hard about what to do about ROS-1 and ROS-2, right? So we have the benefit of having been doing this ROS thing for 10 years. And what comes with that is we have some deployed systems that have been running around since 2014, right? And they're still working, right? I may have gotten rid of that slide, right? But there's an article about it. I can steer you to it if you're curious. Spirit Aerosystems has been talking about that work recently. But it's working, it's running in production. Why would they even bother porting it, right? It's not connected to the internet, it just runs, right? But if there is an issue, or if they want to take advantage of a new motion planner, how do we help them out? Right? If we totally just move to ROS-2 and never look back, how do we help those folks? Right? So this is something that we've put some thought into, and where possible, right, we're asking ourselves what basically can be ROS independent, and that's what you see here, right? So as you notice here, we have these sort of innate capabilities, kind of like the algorithms, the motion planners, solvers, et cetera. They technically really are independent of ROS, right? But then we can easily provide a wrapper to facilitate interoperability with your middleware layer of choice. And of course, then we in our organization work between, at minimum, these three environments, right? So it's very important for us to have this flexibility. We know end users are running into the same, and we're hoping the new capabilities we put out that this is working. Obviously, this is something we want feedback on. Feel free to corner me over by the coffee machine. You can tell me this is not viable. I'm happy here to collect feedback. But this is something we've been experimenting with for about 3 years now. In certain packages and repositories, it seems to be working fairly well. But I'm open to hear feedback on this approach. One of the other things we've been thinking a little bit more about how we're delivering innovation via open source to the shop floor, right? Is not just providing, say, discrete repos or repositories, which look with certain capability, but providing where possible an actual framework, i.e. a collection of nodes. Maybe it stitches together a few things, but basically it's a repo that basically provides you a framework that brings together a number of repos and capabilities. And we call these frameworks, these, so to speak, flexible frameworks. This one is on adaptive surface finishing. I'll talk a little bit about A5 later, which is an agile sort of capability framework. But this is something that has resonated with a certain subset of our audience where, hey, it's one step closer to giving them a starting point, right? They're not having to bring together a bunch of different repos. They can have something, and depending how we package and deploy it, this is really helpful for them to kind of get up and running. And so this is something that we've been working on quite a bit. The workflow sort of is like this. I don't know that these will play, but essentially it's it's panning over, doing a scanning routine. It collects a 3D mesh. We then can do toolpath planning if that video was playing. And then over here you can see the toolpath. It goes into a process planner, because you'll notice in here I don't just have toolpaths on the surface, but I have approaches and departures and transitions. So it handles all of that. And of course, then we put in representative classifiers for how to implement, like say, TensorFlow to do process classification, right? So we work hard to provide frameworks or example implementations to give our audience, our members, something to poke at, if you will. And that's been sort of well received. We've recently turned this into a workshop. You'll notice the GitHub repo is there. We do try to share information. We also hosted a developers meeting where we reviewed this teaching application. We've turned it into a demo that was showcased in Detroit at Automate last June. And the whole point is it originally started off as a 2021 ROSCON workshop that everyone got online and tried to build this in an AWS EC2 instance. It was fun. But since then, right, so our goal is actually we're going to turn this into an advanced topic for our ROS-Industrial member training and how to build a whole motion planning pipeline, leveraging optimization-based motion planning and some of the other tools in the toolbox relative to how we do process planning, i.e. adding approaches and departures, et cetera, et cetera. So we look forward to offering that. This is the demo. That's me running the demo at 2x speed. Right, so here we enable people to position said part. I drew this particular doodle, and then you'll notice when it does it does a 3D reconstruction that's a colorized mesh. So we can either do classifier and generate toolpaths based on the classification, or we enable a user to draw on it and it races within the drawn region. So you can see here I did not select it very well. But that is an example of that framework and turning it in and making it available for users to play with. We talk a little bit about, and I know Daryl's very excited, and the whole AP team here is to have you here. And one of the things they want is this sort of feedback. So we had our big annual meeting in June, co-located with Automate in Detroit, and Christoph was kind enough to stand there at different whiteboards and provide feedback. And these are sort of some of the things we've got feedback on. We had separate conversations in working groups on training and resources, roadblocks to adoption. Like, hey, why aren't more people picking up these things, right? I think I've heard a lot about OpenRMF. I'm really excited about it. But like, what can we do to accelerate? What are people thinking? What are people have read about it? Probably haven't even really experimented yet. Right? What are these things that are roadblocks to adoption? We've been asking that about our ROS-Industrial community. We're very beneficial that our consortium has a lot of opinions. They're very happy to tell us what's not working. They have a lot of questions about DDS and DDS tuning. We have a lot of opportunities there. And so this feedback basically drives what we have to do this next year, right? So we're trying to work hard and put some really hard thought into basically digestible nuggets to help people get up to speed, right? What are some other resources to provide guidance on DDS selection, DDS tuning? What are some other different things relative to these different audiences? I think much like here in this room, we have a ton of different stakeholders, right? It's not just developers, it's not just end users, it's not people building robots. There's even a few others there that we end up interacting with or have questions. How do we service those people? And that's something we're also very excited about. We're obviously, I think like all of us, everyone in the room, right, we're very ready for this COVID thing to kind of be behind us. We can get back to like really collaborating. I think, we did as best we could with in-person or virtual events, right? But nothing replaces getting together, talking over snacks and coffee. We're very excited about that. We've been spending a lot of time going to industry-specific events, right? So we do support ROS-Con. ROS-Con's gonna be in New Orleans next year. We're excited to be there. We'll be setting up a demo, proposing a workshop just like Asia Pacific did in Japan. But we also are having a very renewed focus going where the problems are, right? So these different organizations we actively poke at and support. What are your pains? What are your challenges in adopting automation? Because these are the people, they don't know what ROS is. They're like, ROS, like Friends has been off the air forever, ROS, right? I mean, so, these are the people who they don't feel robots are ready for their applications, like we heard some people say. It's really great to kind of dive into, go to in person where the problems are. I encourage you, if you're in tech development, if you can spend time where the problems are, that's really insightful. I did want to introduce this to this particular audience. This is kind of more recently how we've been getting ROS capability into new applications. So it's great to hear about the collaboration with Singapore governments and universities. That's really helpful. You can have a government industry collaboration. It's very useful. For us, this is really how it's happened, right? So we obviously have a number of open source resources. There's a number of different folks doing R&D, leveraging open source tools. We try to foster that where we can. We work with universities like, hey, did you hear about this ROS thing? It'd be really nice. It gives you a place to start. You can put your work there. It might get reused. You should check this out. And that's really paid off. So obviously, we then sort of obviously do a lot of work within the ROS-Industrial ecosystem. And then we support a number of different funded initiatives, right? So we can get sort of I showed you our scan and plan example, but how does that become say, I don't know, something that's standing on jet aircraft? Well, we have a number of different things. Certain companies we've had, hey, how do I go from open source to bankable capability? They feel there's enough value there, they just fund it themselves. Some people do that. But there are also solution providers who will step in and maybe take it over, turn it into a product. We're definitely seeing startups. Well, that's the startup model, right? In some cases, they bow through, cut through, and come over. That's the startup model. In some cases, right, we'll work collaboratively through different small business initiatives, help them find funding, right? So they don't have to fund all the work themselves. Manufacturing USA is basically our version in the States of a industry government collaboration. And what's nice is they're very often okay with us pushing stuff back to the ROS-Industrial ecosystem. So that's been really beneficial. Certain people get a new capability and a benefit, and then the open source community gets some new capability back or an improved repository and capability. And so we've been excited to support that program across all the innovation institutes in Manufacturing USA. Anyone has other questions about how we run this, I'm happy to talk outside of this particular presentation. So one thing that I heard oil and gas came up in oil rig operations. We were very fortunate that National Oil of Arco, NOV, keynoted our ROS-Industrial conference, right? And I usually try to find keynotes where it's industry doing something interesting, leveraging open source, and ideally even giving something back. It's really nice. In this particular case, NOV was really interested in using industrial robots for their tipping operation. Tipping is basically where they're pulling all the segmented pipe out of the ground. It has to be unthreaded and then set aside, or the inverse, put back in and threaded on and fed in. People traditionally do this role on the rig platform floor, and it's very dangerous and very dirty. So they were working with an industrial OEM provider. You can probably figure it out from the picture on the left. But we supported them a little bit, but they've been ROS-I full members for a long time. But they just recently, well, hence this snazzy video, they released a product. And they're happy to advertise that ROS enabled them to realize this capability. They are now offering this as a solution that interacts with their proprietary software solution. So it's a great story of an end user with a problem, not having to start at zero, taking advantage of open source tools, yet having and realizing interoperability with what is their proprietary software stack as well. So this is great fodder for a keynote speech at my ROS-I conference. But and all joking aside, I mean, this is why we do this work, right? To enable new capabilities, taking research and deploying it. The other thing is I want to talk a little bit about some other work. There's a big push on agility. This is the A5 program. So it does all kinds of work where it'll reconstruct its environment. The user can say, like, yeah, that's interesting. It'll then plan and then do some sanding. What's really exciting about this, we've put a lot of work in this framework. This is basically the pilot of this notion of providing frameworks. And so again, leveraging our relationship with the Manufacturing Innovation Institute, ARM Institute, which focuses on robotics, advanced robotics for manufacturing, we had 2 chances to extend that A5 framework into 2 new applications. And basically one of them was painting. So Lockheed Martin was the prime on this particular project. We worked with an integrator or solution provider, Aerobotics. So they're hoping to adopt this capability and sell systems to all kinds of people. So now we have a pathway to sustainment. We have a hungry end user. Lockheed Martin has to paint all kinds of different aircraft parts. Aerobotics is really happy to offer a new capability to customers. And they don't have to start at zero because they can take advantage of an existing framework and, of course, all the stuff in the ROS ecosystem. So this is an example where, you know, due to some engineering not done, you can see how far the paint gun has to be because the robot itself is not paint rated. So we had to extend the boom out. But this is basically that same framework where an operator can sit there and like say, yeah, use that surface. Yeah, that looks good. Motion plan it. And then it's off to the races. And so this is a really great example of taking basically this, we were able to convert it from the A5 platform you saw before, where it was a big blue robot on an angle doing different kinds of aircraft, to this different platform in around 3 months, right? And then now we're actually making aerospace certifiable coatings. The big limitation is here is they're constrained by the reach of the robot, because this particular platform can't do coordinated motion, so I can't do extended, but that work is on its way, so stay tuned. We're also providing an open source framework. This is funded by the National Institute for Standards and Testing, NIST. And they were really interested, I think we've heard a few examples today of reinforcement learning and how like a real gap for some of these learning frameworks is transfer learning. So NIST provides a standard test bed. It's on the bottom left there. It's an assembly task board. But the question is like, hey, can ROS-Industrial help us create a sort of extensible framework that enables us, hey, handle all the communication with the robot, task abstraction, but then allow researchers to focus on just testing the transferability of their reinforcement learning algorithms. And that's the contact framework. We've since taken this framework and are actually doing real assembly applications with it. Because along the way, we had to have a couple of reinforcement learning algorithms to test how this worked. But it's turned out to be a really interesting approach. You can see there the URL. We hope to move it somewhere. SwRI Robotics is sort of like a holding ground for stuff, either until we move it to ROS-Industrial or if NIST is going to host it, we're not sure. But you can go out there and poke around it. But basically, the idea is that we can actually go across a couple of the different assembly types and verify or assess the performance of reinforcement learning algorithms. And we've had a couple of universities pick this up and provide some feedback. We have NIST is now up and running with this, and we're porting it to ROS2 currently. Reinforcement learning is a seed. I had a few people ask me about TrageOpt and optimization-based motion planning. Well, one thing we learned is that in certain cases, depending how you architect your system, reinforcement learning is great as a seed for your optimization-based motion planning. So we've done a lot of work there. There's some examples write-up on how to build that, and of course, the implementation we use on in Tesseract. So that's been really exciting work. We've been doing a lot of work on improving performance in Cartesian motion planning. So a number of you may have heard of Descartes. Descartes' the Cartesian motion planning. If you're trying to do anything on a surface or in Cartesian space, you'll run into Descartes. But Descartes Lite, you'll see there, also, I don't think it's moved over to ROS-Industrial quite yet, is a new implementation that really accelerates the planning time to get your motion plan solution. So feel free to check that out. We've been working on additive manufacturing. We get a lot of inquiries about, hey, I'm tired of hopping between 6 different software environments to do my motion planning for additive manufacturing. What can ROS do? So we were working with Yaskawa, and we have a couple other interested parties to build on some prior ROS-Industrial work and extend it to like create a full motion planning pipeline for additive manufacturing. And so we did some preliminary testing and shared some results across our membership, and we hope to get something going soon. Another thing that's going on is optimized toolpath for tracking accuracy and velocity. So this is a big deal if you're doing real precision additive manufacturing, and you need to track along, say, the edge of a turbine blade. The robot controller will make trade-offs on velocity and or positional accuracy. So what can we do to the toolpath to improve that performance? So basically, this is sort of what's happening over time as we run the basically input toolpath. You can see here as we run it through and adjust the blending regions and the actual primitive fit transition locations, we actually get reduced error. And that's basically what this GIF is showing. There will be a little bit more of a write-up coming soon. There is an open source repository if anyone's interested in poking around at this. This does basically an optimization of the input toolpath and is fed to your motion planner. So this is all up front. There's a phase 2 that's going to focus on closed looping that. I guess I did one other thing that's going on in the ROS-Industrial America space specifically is addressing ease of use. A couple of for instance, Fraunhofer IPA, thank you, is going to be part of a pilot where we basically are providing a module that plugs into FreeCAD to enable more efficient setup and tuning of work cells. So this will include the creation of the URDF as well as assessment of toolpath planning and some other fun to do things and getting your system set up. The other thing is we just had a big developer meeting on this is Reach. So Reach is a quantitative analysis tool for how your robot can access different things. There's some links here, including a link to the repo. Coming soon is also a heat map for reachability. So when you're going to design your system or you need an input because you have a mobile system that you want to be able to process as much as you can from different poses, this is how this tool came to be. So we're very excited to offer that up to the community. That's it. I just wanted to cover a few things we're offering up to the community and why we are and how it ties to kind of basically the feedback we get from our consortium members. If you have questions or comments or feedback as well, things we can be contributing that benefit this specific community, I'm all ears. I'm here. Thanks. Do we have time for questions?
Yes, now we have 5 to 10 minutes question and answer section. 5 minutes.
Yes, Ruffin.
So you asked the question of what does the community want, or what's missing in terms of the ROS ecosystem. I think one thing coming from like an academic background and having taught ROS or onboarding a lot of my lab mates is sort of there's not like a central story or user interface. Like if you were teaching MATLAB or if you were teaching LabVIEW, there's like this canonical way to enter the ecosystem. In ROS, it's beneficial and there's lots of different tooling to cater to what you need. It's not very unified. Particularly like I think when system designing or orchestrating your system, like when you want to have a minimal example, like the TurtleBot example, you're orchestrating all your launch files, you're trying to figure out what nodes do, what interfaces they provide. In ROS-1, it was like tracking down all the way to ROS-Wiki to find out the documentation that was out of sync with a certain branch. Anyway, You think there's ways we could improve that in ROS2 and simplifying the, I don't know, in LabVIEW, I feel like visual programming was awesome, but there's not quite the equivalent in ROS.
No, that's a great question. I think, I didn't really, the video didn't play, right? But like our long-term vision is to provide at least some like, at minimum, implementation examples and guided tutorials for if you're doing something with say industrial hardware and like classes of industrial applications, like how to start and where to go. So that is definitely like feedback that we've received, and we're trying to chart out what that looks like. The tool here, SwRI, that helps us create URDFs and set systems up, will eventually have some of that, a little bit of that visual programming element as well over time, but that's on the roadmap, if you will. I agree, ROS2 offers this opportunity to do some of that, because there was a lot of, let's say, consternation over like some of the breaking changes from ROS1 to ROS2, but that also gives you an opportunity, right? And so we are taking a look at that, and hence we're offering more complete built-out examples as well, right? To that point, right? Like, what is the entry point, and where do we start? I would like to say at least how, ROS1 had the wiki and everything, and how you're structuring the documentation is a good start. So I think on the ROS side, it's trending, right? And we're trying to come up with like what are complementing tools to help people, right? Examples, bite-sized tutorials. To your point, right? Can we get to a visual programming? And those are definitely things that we're looking at. Yeah, absolutely.
Thank you.
Sorry, as well.
No, thank you. Thank you, everybody. I'm around, so feel free to ask questions.